De nada. Yes. Hi, welcome to my YouTube channel. This is Shauna Muller, and we're going to talk about trigonometry today. Alright, so let's do some practice with our fluencies. So what I really want to do, first of all, this is counting by threes, right? If we go around our circle using degrees. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Alright. I think I'm going to go to my 45s now. So my 45s, I already know that my 9s are my benchmarks. So I have a 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So those are like my benchmark numbers. I always do those first. Welcome, Johan. Okay. I feel like one of those girls on YouTube that is like getting ready for to show you a hairstyle, dude, and she's like, people are coming in and she's like saying hi to them on the chat. Okay, yeah, the makeup ones. I had to watch one for myself because my daughter watches it. I'm like, what's the big deal? And like, yes, exactly. And then like 10 minutes in, I'm like, this is such a waste of my time. Okay. All right, guys. So I'm recording.
Sorry. Oh my God. I'm so sorry.
Sorry. Sorry, viewers. Okay. So we have 45 degrees. Then we said that the magic to this pattern is as I increase on my hundreds, I decrease on my tens. So this is adding a 1, but it decreases it to 3. Then as I add to my hundreds, I get a 2, but I decrease to 2. And then I add to 3, but I decrease to 1. So that was kind of what we did with our 45s. Now I want to practice going around our unit circle and talking about our reference angles. So our reference angles words, which you should have put on your paper yesterday. So we have 30, 45, 60, but in radians, this was pi over 6, pi over 4, pi over 3. Correct? So I'm going to go through the 45s. I'm actually going to go through both of them. We're probably going to have a quiz on this on Friday. All right, just on the unit circle and if you can fill this thing out. Okay? So I'm going to go through my 45s. So I always do my benchmarks first. So this is 0 pi. This is pi. All the way around is dose pi. Thank you, Robert. All right, now that I have my full pi's and my 2 pi's, I'm going to go to my halves. So I'm going to go to, if this is 0 pi, and this is a whole pi, then this must be half a pi. If this is 1/2, 2 halves, this must be, ooh, that wasn't good. Don't do that. 3 halves. I'm really having difficulty right now. Technical difficulty. There we go. So this one's going to be 3/2 pi. I got all these dots all over the place. All right. So 1/2, 2 halves, 3 halves, 4 halves. Now I'm going to go through my 45s. So my first one is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and then 8/4 is back up to 2 pi. All right, easiest one of all. Now we should go to the 30/60, right? Those aren't as much fun. I'm going to show you 2 different methods. Okay? Let's see which one you like better. But let's wait for Kendra and Matthew to finish their game. Are we done? Okay, fantastic. Didn't want to encroach on your time. So let's do our benchmarks first. So this is 0 pi. This is half, 1/2. Let's do it consistent. Pi over 2. This is pi. So if that's 1/2, 2/2, 3/2, and 4/2, which is 2 pi. Okay, so if this is just confusing you so much when we go from thirds to, or from 6s to thirds, don't fret. You can just count by 6s and reduce later. So let's cut and copy this onto my last page. Cut and copy. So put that in the corner right there. So let's start with our 6s. So I'm going to do them in red. So my 6s, actually, let's go with green. My 6s are 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, we're done. But now I have to go around and I have to simplify. I have to simplify this one, and this one, and this one, and this one. Correct? Those all need to be simplified. All right. There's an easier way to do that without having to simplify. Remember how I talked to you guys about bow ties and butterflies? All right. So if these are my butterflies right here, those are the ones that have 3s. They're in 1/3 pi. My bow ties are the ones that are in 6s. So let's recreate this, and I'm going to go around and I'm going to do it using my bow ties and my butterflies. All right, it's just a pattern. So I'm going to go ahead and copy this screen so we still have it. Now it's page 3. Go ahead and erase these. I should have left my benchmark. Doesn't hurt to do it over and over and over again. Look what I did. All right, let's do that, and that, and that, and that, and that. Now I just have to fill these in. So this one, pi over 2. And here's my pi, and I still have my 3 pi, didn't erase that one. Okay, so I'm going to use my bow ties and my butterflies. I'm going to start with my bow ties, because that one's the easiest one for me to do. I understand my 6s a lot. I'm just going to continue to, maybe we should do those in red. And you can see them better? All right, so we're going to do these in red. Yeah, because the blue's already there. I'm only going to do those, and then the other ones are just going to appear to you. Okay? Right, Israel? All right, so this first one is the easiest one. It's my reference angle, right? It's pi over 6. Fidel, can we please stop making swords? Fantastic. Just so you know, viewers, this is an Algebra 2 class. Okay, fantastic. And we're mostly juniors who have their licenses. Okay, put the sword down. All right, so we have pi over 6. I'm going to look at the, and Matthew, can we please stop twirling the protractor? Appreciate it. Okay, all right. So we have pi over 6. Then over here, this is pi. So what's one less than what we would call this 6 pi over 6, right? Because this would be 1, 2, 3, 4, 5. Thank you. So this is going to be 5 pi over 6. And this, okay, let me stop. Do we understand that all the way around is pi, which is really 6 over 6? It's 6 pieces. So one up is going to be 5 pieces. And one down, Sebastian, is going to be 7. He was second guessing it, but he knew. So if this is 5, 6, 7, then this side is 1. This one would have been 12. So this one is 11 pi over 6. You guys can remember that, right? 1 less than 12, 1 more than 6, 1 less than 6. Okay, so finally, the only thing left are my thirds. They're the only ones left. So let's do those in black. So this one, see, there's no room. Like, this one has to be 1/3, pi over 3. This one has to be 2/3. This one is already 3/3 because it's reduced. This one is 4/3. This one is 5/3. Is that helpful? Yeah, for some of you? Yes, Ireland. I'm just going to help you out here right now. That's a great question. I only want to know, can you put just 1/3 times pi? Yes, you can. That is equivalent. 1/3 pi. If that makes more sense to you, go for it. I think I'm just being lazy. It takes more time to write a 1 than to just put the pi. Oh, Fidel. Let's just get rid of everything on the table. There we go. Okay. All right. Now you have no distraction. Okay. All right. That's our review. We'll do it again tomorrow. Okay? We're going to keep reviewing. So let's go ahead and make some connections today. So each one of you has a different size, well, some of them are doubled up, but there are different size triangles on each table. Each table group has one triangle, okay, and one protractor. Oh yeah. Where's your triangle? Oh, okay. So Laves, you're going to be in charge of the protractor and the triangle. Okay. He already had the triangle. You can oversee that Laves is measuring correctly. All right, so what I'd like you to do is I'd like you to use your protractor. Okay, let's see if I have my tools here. Protractor, 180 degrees. Do you guys remember how to measure with the protractor? Okay. So this right here, this is a straight line, correct? So this is a straight line. You guys get it? This is a straight line right here. Right here. This is a straight line, and you're going to line it up with your straight line. Then the middle of it has to touch the corner. Do you see that now I can measure the angle, and the angle is at 90 degrees. So let's turn the triangle. Let's see if I can turn it. Let's turn the triangle so I can measure the other side. Is it off? Okay, so we're taking the bottom of it, right? And we're measuring. Oh, I measured the wrong side. I want to measure this side. There we go. All right, does that look like it's lined up pretty good? So I'm going to go ahead and look at that measure. That measure says 118. It's probably more like 120. Does it make sense for this angle to be 120? It does? If 90 is a right angle, doesn't that have to be smaller than 120? So wouldn't it be the opposite, which is 60, right? Okay, you guys all measure your third angle, your smallest angle, and tell me how much it measures to. Measure. Who's in charge? You already got it? Okay. All right, let me pause it for 1 second. Okay, so let me go back and put my triangle so that we can see it. I want to get rid of this. Okay. Let's move this one over here. So this was 90. My bigger angle was 60. So what's this one have to be? 30. Who had the smallest triangle, the little tiny one? That one. What was the angles in that one? It's little. I'm going to say 90, 60, 30. What about the one that was like a little bit bigger than this one? So there's 4 different sizes. What'd you guys get?
We got 90, 60, and 30.
90, 60, and 30. Well, that doesn't make sense. How could they all be similar?
It's because of algebra.
Okay, so this takes us back to geometry, right? It doesn't matter the size, right? They all have the same angle measure, right? Just a different scale factor. Not the same area, exactly. All right, so we're going to talk about some connections with these. So the next thing I need you to do is I need you to measure the smaller leg. Now, when I say leg, which part of the triangle am I speaking to? Okay, good. Most of you are pointing to the right parts of the triangle. What's the longest leg? This one. It has a special name. It's hypotenuse. The hypotenuse. Okay, guys. You guys are so excited to say that word. Hypotenuse is, the 90-degree angle is always pointing at the hypotenuse. Right? So, if I'm asking you to measure the shorter leg, this is the legs. These are the legs. Okay? Because the legs support that hypotenuse. They're both smaller. The hypotenuse you learned in 8th grade is the longest side of a right triangle. Okay? So, everybody who, at your table groups, measure your shorter leg for me, please. We need a bigger one. We need the last one. It still didn't do it. There it is. There we go. Now we've got another one. There we go. Okay, so smallest triangle, what'd you get? What was the smallest leg? Wave. Smallest leg. Yes. I know, but I want you to measure it. Who else has a little triangle that they measured? Johan? We don't know how to measure. That's the problem. Madison, put it away. What? I did. I'm not giving it back to you either. Okay, on to triangle. Wait, measure it. Measure, on to the next biggest one. How big was this one? Yours? Okay. Yours, that means yours is this one, the 3. Yours was about 2. Okay? 1. So all we're left with is the biggest one. Who has the biggest triangle? For lack of Algebra 2 students measuring and being motivated to measure right now, I'm going to say 4. Right? Wouldn't you say 4? Okay. Now, I'd like you to measure the hypotenuse for me. Measure the hypotenuse.
So we got 5.5.
I'm waiting for the other two. What's this one? 5, 4, 3, 2, 1. You guys aren't taking this seriously on me. Alright, I need this one.
3.8.
Okay, so I'm guessing, since these are paper triangles, 3.8 is probably 4. What do you think this one is? Okay, so let's do this. Guys, you guys are chatty today. Hold on. I know, it's because of the testing. I get it. That's why we're just doing introduction today. What if this was 6? What if this was 12?
24.
What if this was 18? What if this was 100? Does everybody see the connection? It's a scale factor, right? It's a scale factor. So the hypotenuse is twice as big as that shorter leg. All right, let's explore the longer leg. Let me just make sure that I'm not going to give it away right now. Okay, so I know on any triangle, let's just call it my unit triangle because it's 1 unit on the shorter leg. Let's see how much the longer leg is using Pythagorean theorem. Okay. Okay, so why can't it be 3 units? It can't be bigger, right? This side can't be bigger than this side. You think it's 1.5? Okay, I'm going to use a squared plus b squared plus c squared equals c squared. Sorry. So which one's a? It doesn't matter. Right? b squared plus a squared equals c squared is the exact same thing. And guess what? C squared equals a squared plus c. They're all the same thing. Yes. Or a squared equals c squared minus c squared. Right? Or, okay, that's enough. So the most important part is that this is c. Okay? So let's take c squared, which is 2 squared, and let's say we know 1 squared, but we're trying to find b squared. So I have 4 equals 1 plus b squared. Then I subtract and I get 3 equals b squared. Therefore, when I take the square root of both sides, b equals root 3. So this is root 3. Let's pick one. Let's pick one of these. Which one would you like to pick? The green one. Okay, let's do the green one. So if the green one is 3, so we're going to take this green one, and we're going to copy it, and we're going to go over here, and we're going to open a new page, and we're going to paste it. This was my 3, 6. All right, so 6 squared equals 3 squared plus b squared. Solve it. Do it. In your table groups, work together. Okay. So you guys are doing a fantastic job, and normally Mrs. Mahler would never mark you down for not simplifying. It's the same answer. correct? So this is 36 equals 9 plus b squared. If I subtract 9 from both sides, I get 27 equals b squared. If I take the square root of both sides, I get b equals square root of 27. And normally, you're not wrong, right? But for the purpose of this lesson, I'd like to take it one step further and say that the square root of 27 can be simplified by 9 times 3. The square root of 9 is 3. So that simplifies. So let's go back up here. So 3 root 3. This is 3 root 3. What was the first one? Root 3. Let's go back to this one. This is going to be 2 root 3, 3 root 3, 2 root 3, 4 root 3. Are we catching on yet?
Oh, wow, we should have never wondered.
If you have the connections there, you don't even have to do any work. So that longer leg is bigger by root 3. Okay, I'd like to just make one point about this. Nope. So let's copy this one. Let's open a new page and let's paste. This will be the most common misconception. Most of you will remember that this is 1. Some of you will remember that this is 2, but the most common error is to put this one as root 3 and this one as 2. Do you know why? Because this is the bigger side and that looks like a bigger number, right? Is this a bigger number? What's 2 in root form? Well, root 4. So now which one's the bigger one? This one's the bigger one, but which is the bigger side? This one, the hypotenuse is the bigger side. So whenever you have a hard time with that, you know another way I remember which one's which? So this is 2, and this is root 3. This degree is bigger, right? This is 90, this one's 60, and this one's 30, and the root 3 goes with the 30. That's another way I remember it. Okay, I've got another one for us to do. So this one is my first special triangle. It's my 30, 60, 90, and it's always going to be scaled to 1 to root 3. Jonathan, you better not have a phone. Oh my gosh. So those who are watching, Jonathan just raised one hand and left the other hand underneath the desk. Okay. Alright, so here's our first special triangle. Let's talk about our second special triangle. Alright, so originally I was going to have you cut out each of the rectangles. You're going to realize that they're not rectangles. They're in fact squares because they both have the same size sides. Okay, again, I'm going to use a triangle, in case nobody has told you before, is half of a square. Right? Hopefully. Hopefully we've all seen that before. All right. So this square that turns into, or this half of a square, turns into a triangle that's got, it's not going to be perfect. I don't like it. You know what I'm going to do? I'm going to take this one, I'm going to copy it, paste it, and I'm going to turn it And I'm going to cut it. Let's see. Ooh, it's still not straight. That's unfortunate. I don't think I spun it right either. Oh well. I gotta cut it right. That's okay. I can. I'm just being lazy because I could bring it up on here. That's not going to give me a perfect 45-45 though, which is what I'm going for. We'll try. I'm getting frustrated. Okay. All that for nothing. Okay, so I'm trying to make a triangle. I want to know how long my hypotenuse is. Because these are cut perfectly in half, this 90-degree angle is going to make a 45. Correct? Okay, so how do I know? Because I'm cutting 90 in half. Half of 90 is a 45. So this is a 45, 45, 90. This is a 45, 45, 90. And this is a 45, 45, 90. Okay, let's use Pythagorean theorem. Let's use it with this one. So 1 squared plus 1 squared equals c squared. This one's the easier one. You don't have to subtract. So 1 plus 1 is 2 equals c squared. So c is root 2. Square root 2. Let's do this one. 2 squared plus 2 squared equals c squared. 4 plus 4 is 8. C is square root of 8. 4 times 2 is 8, so it's 2 root 2. Still not convinced? Let's do this one. 3 squared plus 3 squared equals c squared. 9 plus 9 is 18. Square root of 18 equals c. 18 is 9 times 2, which is 3 root 2. What connection do you see here? All of them are going to be, the hypotenuse is going to be larger by root 2. Okay, I think, so there's my special triangle there. So if I have 100 and 100, this is going to be 100 root 2. Somebody came up in 5th period at the end of the period and said the way they're going to remember it is that root 2 has 2 of the same angles, and the one that we use root 3 with has 3 different angles. So I thought that was a nice way to look at it. So thanks, Jocelyn. All right, Jocelyn. Okay, so that's the end of today. So tomorrow we're going to dive into the unit circle with our special triangles. Okay? All right, fantastic. Thank you.